This is question 5 on the MTH312 Midterm 2. So this question is telling us, consider the following system of differential equations, and we want to use Laplace transform to solve for x of t only. So that's really important. We don't want to waste time and start solving for y of t or both. We just want to find x of t. Okay, so let's go ahead, and first what we want to do is we want to turn our use our d operators essentially. So we want to turn these equations into the d operators. So let's go ahead and do that. So x prime, that would just be dx plus 3y, and it's equal to t squared. And then we have 2x plus y prime, which would be dy, and that's equal to t. So there we go. Those are our equations. We have them in the d operators. So what we have to do now is, well, we have to take the Laplace of this. So if we take the Laplace of both of these equations, let's write that down. So we're taking the Laplace now of dx plus 3y is equal to t squared, and then we're taking the Laplace of the second equation as well, 2x plus dy is equal to t. So there we go, we're taking the Laplace of both of these. And so now that if we take the Laplace, what we're gonna get is, these also are all on the formula sheet that's used for the exams in this class and in general. So we know that if we want to take the Laplace of dx, which is like the derivative, right, it's going to be s x of s minus x of 0. And so just to recall, we have those conditions, which is why they actually gave it to us. So s x of s minus x of 0 plus the Laplace of 3y, this is going to be 3 capital Y, and then the Laplace of t squared is just going to be 2 over s cubed. Now let's take the Laplace of the second equation. If we do that, we'll get 2 capital X of s. Also, this should be a 3y of s, just like so. So we have 2x of s plus s capital Y of s, and it's equal to 1. Oops. It's equal to minus y of 0, and now it's equal to 1 over s squared. Okay, so obviously we know that x of 0 and y of 0, these are both equal to 0, right? So we can pretty much neglect it. So we're left with s of x of s plus 3y y of s equal to 2 over s cubed, and 2 x of s plus s y of s equal to 1 over s squared. Okay, so there we have it. Now what we want to do is we want to solve for x of t. We want to find the Laplace. Obviously we're taking the Laplace, and we want to find x of t. Well, if we want to find x of t, we would have to find the Laplace of what? The capital X of s. So what we have to do is we want to do elimination on these equations, so that when we add them up, we can solve for this x of s. So what can we multiply to the two equations? Well, if I want to solve for x of s, obviously we're going to have to eliminate the y of s's. So what we can do is we can multiply -3 to this equation and multiply s to this one. That way we'll get 3s y of s, and in the second equation we'll get 3s y of s, but a positive, and we'll see that they'll cancel out once we add the equations. So we get s squared x of s now plus 3s y of s equal to s times 2s cubed, which let's just write it as 2 over s squared. And in our second equation we have, so 2 times negative 3, that is negative 6. Negative 6x of s minus 3s y of s, and that is equal to negative 3 over s squared, just like that. Okay, so now we can actually add our equations. And you'll see that once we add our equations, if we add them, we can see that this will cancel out with that. So what we're left with is s squared x of s minus 6x of s is equal to 2 minus 3 s squared, which 2 minus 3 is equal to negative 1. So we're left with negative 1 s squared on this side. So this is what we have now after adding these equations. Now, after we add these equations, we want to solve for x of s. So what we should do on the left side of the equation here is we want to factor out that x of s. So if we factor out that x of s, we'll get x of s, and we'll have s squared minus 6, that's equal to negative 1 over s squared. Which now, if we actually solve for x of s, we're going to get negative 1 over s squared times s squared minus 6. So boom. Now, if we want to find x of t, what we have to do is we have to take the Laplace inverse of x of s, because this will result in x of t. So we need to take the Laplace inverse of the following. Now we're going to have to do either a partial fraction decomposition or something along the lines of that using one of the theorems, but I believe if we just do partial fraction decomposition, as I believe it was intended to, we'll see shortly that it's pretty quick. So what we have to do now is we have to, obviously, if we want to find the Laplace inverse of this, we're going to do partial fraction decomposition. So let's go ahead and do partial fraction decomp. So this is going to be equal to a over s plus b over s squared plus cs plus d over s squared minus 6. And so this then turns into as s squared minus 6. If we get rid of the fractions, negative 1 equal to s squared minus 6 plus b s squared minus 6 plus cs plus d s squared. So let's go ahead and further, simplify. we'll get negative 1 is equal to a s cubed minus 6as plus bs squared minus 6b plus cs cubed plus ds squared. So we've distributed everything now. So now we want to group all them up so that we can start solving for the constants. So for s cubed, we can see we have a and c, a, so we would have a plus c, and then for s squared, we'll have b plus d, right, because we have the bs squared and the ds squared, and then plus s. For s, we have just negative 6a, and then this is obviously minus 6b, which is like sort of a constant. So now if we can go ahead and just start solving for our constants a, b, c, and d, let's start off with b, since we're actually able to find a numeric value. So for, let's just say k, for constant, we have negative 6b, and it's equal to negative 1, which if we solve for, we get b is equal to 1 over 6. Let's then move on to s. For s, we'll have negative 6a, and it's going to be equal to 0, which means a is equal to 0, and so that means s squared. We have b plus d, which is also equal to 0, meaning that since we already have b, this means d is equal to negative b, which means we know our d is going to be equal to negative 1 over 6. And then s cubed, we know that it would be a plus c is equal to 0, and we know since a is 0, this just means c is also 0. So there we go, we found all of our constants. Let's now replace it. So for a is 0, so this pretty much cancels out. B is 1 over 6, so we'll have 1 over 6s squared. And then we know that c is equal to 0, so we just left with d. So b1 over 6 s squared minus 6. There we go. So now let's go ahead and find the Laplace inverse, because remember this right here is just our x of s technically, and we're trying to find the Laplace inverse of it. So I'm gonna need a new page. So let's add a new page. So we want to find the Laplace inverse of the following. So we can actually split this into Laplace inverse of just 1 over 6s squared plus the Laplace inverse of 1 over 6s squared minus 6. And then we can take the constants out. So if we take the constants out, we'll have pretty much 1 over 6 Laplace inverse of 1 over s squared plus 1 over 6 Laplace inverse of 1 over s squared minus 6. Now, we know that the Laplace of 1 over s squared is pretty simple. We know that 1 over s squared would just be t, but on the other hand, 1 over s squared minus 6, we have to do some modifications before we can actually do the Laplace inverse. You see this right here is, we want to go off of one of the hyperbolic functions, the sine h or cos h formulas. And so the formula for this one would be the sine h formula, which we know is going to be essentially a over s squared minus a squared. So we know that a squared is what? Well, in this case, our a squared is equal to 6, meaning if we wanted to find a, our a would obviously be root 6. So we need to multiply root 6 to the numerator and denominator. So we'll have 1 over 6 t plus, we multiply, so we will have 1 over and then 6, 1 divided by 6 times root 6, Laplace inverse of root 6 over s squared minus 6, which now we can see is the proper form for sine h. And so this right here, let's just keep writing. We have 1 over 6t plus 1 over 6 root 6 sine h root 6t. So let's factor out that 1 over 6 just because we can, and let's write our final x of t. So the x of t in this question is 1 over 6 bracket t plus 1 over square root 6 sine h root 6 t. And that is the answer to this question. To this question, I just realized that there's actually a mistake. When we're writing the partial fraction decomp, I forgot that d is negative 1 over 6, meaning this right here would be negative 1 over 6. So the answer is pretty much going to be almost identical, aside from one sign, which I'll fix right now. So this is the actual answer.